So does anyone here has any questions on your homework 6.2 and 6.3? Anyone have any homework questions for me for 6.2 and 6.3? And I'll go a little bit on 6.3 today because the unit circle is very important. So I will show it to you how you guys read from the unit circle. That will be mostly 6.3 material. Anyone have any questions for me for your homework that is due tonight, 6.2 and 6.3?
Yes, can you go over question 12, please?
Question what?
12.
On 6.
On the 6.3.
2?
Yeah.
6.2, question 12. Anyone? Besides 6.2, question 12. If you do, you just need to either stay back after class, you can ask me, or you can email me. So we're going to do 6.2 question 12 here. And if you don't want to voice out, you can always type in the chat room. I can help you with that. So 6.2 question 12. So we have 6.2 question 12. So this is asking us to figure out what is the angle for cotangent when the value is 1. So we do it the backwards way. So if you recall what we did last time on chapter 6.2, which is, I can show you the notes, page. So this is the, I think it's page 2. Sorry, we just open up for page 2. So this is the notes that we have for 6.2. So what the question 12 is asking us is that they used to be asking for sine, like angle. You give me the function. For example, sine 30 degrees is 1/2. Cosine 30 degrees is √3/2. But this question asking us the opposite, means that cotangent of what degree is 1. So what you need to do here is you look under cotangent and you look under 1. So cotangent 45 degrees or pi/4 will be 1. So in this case, it will be 45 degrees or pi/4. So this is what we call as the inverse trigonometric function here. So if they ask us about, if they give us the value of the function and they give you the function that says cotangent, they ask you for the degree missing. So what you do is you're looking for cotangent, you're looking for the value, and then the answer is the degree here. So so that will be the answer for this. For same thing with question number 10 here. So they give us the cosecant, but the function value is 2. So they want to figure out what is the degree in radians. So what you do here is you look at the cosecant here, and the value is 2. So in this case, the cosecant 30 degrees or pi/6 is 2. So your answer in this case will be either 30 degrees in degree or pi/6. So this is how we do this kind of questions, and we call this as inverse function or inverse trigonometric function. So you will learn this at the end of chapter 6 here. Okay. 6.2 question 9. This is the same. So this is going to be question 9. Sorry. This is just straightforward from here. So for this, the question is given us cosine 30 degrees. So cosine 30 degrees in radian is pi/6. And the cosine 30 degrees in this case is the value is √3/2. So this will be √3/2. That's my, there you go. √3/2. So that's how you do question number 9 in this case. So mostly this chart that I used to have in 6.2 page 2. You can find this in your email or in D2L. Is what we are really concentrate on. So this is something that you guys really need to know. This is very crucial in this case. So the next thing we're going to talk about here is 6.3 question 8. So anyone have any more questions on 6.2 before I move on to 6.3? Yes, so that's what 17. So in this case, question number 17 is asking us about the use the given function value to find this. So secant theta is 5. So you need to find what is cosecant, cotangent, cotangent, and sine. So since we know that secant and cosecant is what we call as the reciprocal function. So in this case, in order for us to figure out what cosine theta is, you just do reciprocate in this case. So it's 1/5 here. Now I'm not going to go over a lot of questions here. So so Sanders, this is teaching, not doing your homework here. So please stay back. So I'm probably do 17. So Sanders, you might need to stay back after this class, after the Zoom for 19. So I'm not going. If you have more questions, I cannot go through this because otherwise I'm not teaching the class. So once you got this, so what you need to do here is you have to draw your triangles, your right triangles. And I'm still doing the 6.3. So as you know that this is your theta, and cosine in this case is cosine is adjacent over hypotenuse. So your adjacent is 1, your hypotenuse is 5. So you need to figure out what is your opposite in this case. So you have to use your Pythagorean theorem to figure out. So let's say this is your A. So a squared plus 1 squared, which is 1, is equals to 25. So 5 squared. So in this case, a squared is 24. And then you have to take the square root of it. So again, I'm not taking attendance. Class, I'm not even talking about attendance yet. So Yang, do not do that. I will count you absent in this class. So 24, what times what is 24? You need to break it down. This is actually 4 times 6, and 4 is a perfect square of 2. So in this case, your adjacent in this case, or your opposite in this case will be 2√6. So once you get this, then you can figure out what is cotangent theta is. Anyone know cotangent theta is what over what? Anyone know? Tangent theta is what? Tangent is what over what?
1/tan.
I know, but so using SOHCAHTOA, using the right triangle, what is tangent in this case?
Opposite over adjacent.
Opposite
over
Adjacent.
So what is cotangent in this case?
Opposite A over O.
Adjacent over opposite. So what is adjacent in this case?
1 over 2
by what?
2 squared of 6.
2√6. And how do we do?
Multiply by 2 square root of 6.
No,
over
just
2.
√6. Just multiply by √6.
Oh.
Okay, just the roots in this case. So the √6 is on top because 1 times √6 is √6. This will give us what in the denominator? What is 2√6 times √6? Anyone? What is √6 times √6?
6.
6. What is 6 times 2?
12.
So that will be 12. Yep. So your answer in this case will be √6 over 12. Okay. So this will be √6 over 12. Now, sorry, this is wrong. So because it should be on the outside. So make sure you guys know how to put how to type this correctly. So make sure the 12 is not in the square root. The next one we have is cotangent 90 degrees minus theta. So we have a rule for this. If you remember, if you have a cotangent 90 degrees minus theta, what is that going to be? Cotangent 90 degrees minus theta. We have a identity here, or a formula. So which identity are we using for cotangent 90 degrees minus theta? The cofunctions, the reciprocal, the quotient of Pythagoras. Anyone?
Co-functions.
So cotangent 90 degrees minus theta is actually the same as what?
Tangent.
Tangent. So this is actually the same as tangent theta. And as you know that tangent is opposite over adjacent.
Yeah, 2 square root of 6.
So it's just 2 root 6, you're correct. Okay. And the last one, I don't have time to type it in there. So this is 2 root 6 sine theta. So you can also use this to find sine theta. So sine theta is what over what?
Opposite over hypotenuse.
All right, opposite over hypotenuse. And what is opposite in this case?
2 root 6.
And your
over
hypotenuse is
5.
5. So this will be your answer for the sine. And this is your answer. So I don't have time to type it in. So make sure you guys know. So you are doing quite a lot using SOHCAHTOA here. Once you get yourself a triangle, then it will be very, it's not that too difficult to do it. Okay. So this is 6.2. If you have questions, do stay back after this Zoom. I can help you with it. I'm going to continue with 6.3 here on. Beside question number 38, does anyone have any questions on 6.3? 38. So question 38 is given us the same thing as what you guys did before. So remember last time, I'm going to save this first before I move on. This is online homework 6.2. So if you remember, the last time we talked about the 6.2 page 2, this fellow. So this question 38 is asking the same thing that we just did. So if you look carefully here, they ask you for sine theta is √2/2. So you need to figure out what is theta in this case in degree and radius. So this kind of the same thing we did like early on in 6.2. So sine theta, you want to figure out √2/2. So what angle? Because when I ask you for degree, so what angle give us sine theta? What angle give us √2/2 for sine?
Excuse me, I have a question.
Yes.
Yeah, do we have to memorize this chart like
Yes.
for
Yes.
exam, like, or is there any?
Yes. I already told you on last week that you have to either memorize it or draw it your own. You have to draw it your own here.
Okay, is there any note
No.
like for the exam? No, no. Okay.
No.
Okay.
So you have to actually take out a piece of paper and start drawing this table up, because this table is either you use this table or you use the unit circle. So I'm going to teach you how to use the unit circle. So in the test, I will provide you the unit circle, but it's blank. So it's going to be a circle like this without any numbers, without any this stuff inside. So I will teach you how to use this today. It's the same thing as this table. So either you use this table or you use the unit circle approach to do it. They are the same.
Okay, thank you.
And no matter what, you have to either know it or memorize it. So it's not provided to you. So this question is kind of the opposite of what we did. So the same as what we did early on. So √2/2 for sine is 45 degrees and pi over 4. So your answer in this case is 45 degrees or pi over 4. So this is what we did last time in 6.2. However, in 6.3, it's a little bit different here. It's because now the angle that we are asking for is not between 0 to 90 degrees. So it's gonna be from 0 to 360 degrees. So in this case, it consists of two answers. So if you remember, if you watch my video in 6.3, when you look at the all 360 degrees, that is a very important stuff that you need to know is all students take calculus. So this is symbolized very important stuff. So make sure you guys know this. This all means that this is quadrant 1, 0 to 90 degrees. All in this case means that all 6 trigonometric, sine, cosine, secant, cosecant, tangent, cotangent, they're all positive. For the quadrant 2, the sine and the cosecant will be positive in quadrant 2. The rest, tangent, cotangent, cosine, and secant will be negative. And then in quadrant 3, tangent and cotangent will be positive. The rest will be negative. And quadrant 4, cosine and secant will be positive, and the rest will be negative. So since this is a sine and this value is a positive, so looking at this table, we find out that quadrant 1 sine is positive, and also quadrant 2 sine is positive. So in this case, you have to figure out what is the reference angle for 45 degrees in quadrant 2. Okay. So in order for us to do this, you can either use the unit circle approach here. So 45 degrees is quadrant 1. And quadrant 2 is going to be this one. And the reason why I know this is because as I mentioned in last week, anything over 4 is correspond to 45 degrees. So pi over 4 is 45 degrees. 3 pi over 4 will be 45 is correspond to 45 degrees. 5 pi over 4 is correspond to 45, and 7 pi over 4 is correspond to 45. So since sine is positive in quadrant 2, so your answer in this case is 135 and 3 pi over 4. So for this question, it will be, for this answer, it will be 45 degrees and 135, or in radian is 3 pi over 4. I'll just use pi. Now, the next one that we have in this case is sine theta, but this is in negative root 2 over 2. So as you remember that the root 2 over 2 is the same, is 45 and pi over 4 as what we did in part A. But in part B, it wants negative. So since it is negative, that it has to belong to quadrant 3 and quadrant 4, because in quadrant 3 and quadrant 4, sine is negative. So how do we figure out what angle is quadrant 3 and quadrant 4? Is again, we use this unit circle. So 1, 2, 3, 4. Since we're looking at pi over 4, can someone tell me what angle is correspond to 45 degrees or pi over 4 in radian in 3 or 4? Anyone?
Can you repeat the question real quick?
What angles in quadrant 3 correspond to 45 degrees of pi over 4?
Pi 3/4.
Will be, I'm sorry?
First,
Quadrant 3 is here. Don't forget, this is quadrant 3.
Oh,
And this,
5 pi over 4.
5 pi over 4, or in degree
Yeah.
is 225, right?
Mhm.
So this will be 225
No,
or
40.
5 pi
40.
over 4. So this is quadrant number 3. And also because it is negative in quadrant number 4, so quadrant 4, what is quadrant 4 in the unit circle?
7 pi over 4, which is 315 degrees.
So this will be 315 and 7 pi over 4. So this is how we do this kind of questions. And again, you will do this again in the 6.6 at the last section of chapter 6. We call this as inverse trig functions. So make sure you guys know how to do this. This is very
Can you go
important.
back to the, yeah, so for this one, right? We had the third one. Why did we put the fourth one, like the fourth quadrant?
Because this question is asking us from 0 to 360.
Mm-hmm.
0 to 2 pi means the whole revolution.
Yeah,
So when because in sine, there are 2 positive and 2 negative. We talk about whole revolution.
yeah,
Positive is in quadrant 1, 2, negative in quadrant 3, 4. So that
3
means
and
you
4.
so
Yeah.
you have answer in 3 and 4 quadrant 4.
Oh yeah, I already knew how to do this. Just that I was a little bit, I was like, why we keep putting 2? So now I
You
do
have
get it.
Yeah, because you the question is asking from 0 from the whole circle here, the whole revolution here.
Yeah.
So you have to do all those things.
All right.
So this is very important. Okay. So now I'm going to teach you how to use a unit circle approach here. So the first thing first is you need to know how to get these coordinates. Now, if you know your first quadrant coordinates, the rest of them is very easy. Okay, so this is what we call as a unit circle approach. So I'm going to teach you how to do this. So as you remember that from last time that from the sine, I'm used by the old one. Sorry about that. So for this, if you remember this, so on 30 degrees, every time when you take a look at the coordinates, your coordinates always have x and y, right? Okay, as usual, x and y coordinates. So this is very important. This is something that you guys need to know. X coordinates, this is for what we call as a unit circle, the one that I'm not talking about here. So unit circle, your x coordinates is always belongs to the cosine theta, and your y coordinates always belongs to sine theta. If we're talking about unit circle, so what happens in this case is if you have a coordinates like this, which is an 30 degrees, and so this is going to be an x value, and this is the y value. And x value in this case is always cosine. So if you look at this table, cosine 30 degrees is √3/2. So that's why the square of 3/2 is on here, is because that is when cosine theta is x. And then the y value here is your sine theta. And if you look at your sine theta is 1/2. So you got the x and y here, where x in this case is your cosine, and y in this case is your sine theta. So that's why the 30 degrees here is square of √3/2 and 1/2. And then when you look at 45 degrees, your y is your cosine, your x is your cosine, and in this case is √2/2. And your y degree, your y in this case is your sine theta, in this case is also √2/2. So you notice that for the 45 degrees, your xy value is √2/2 and √2/2. And then for 60 degrees, you find out that x in this case is your cosine. Cosine 60 degrees is 1/2, so that's why you get 1/2 here. And then you will get √3/2 for sine 60 degrees. So this is the basic of your unit circle approach, which a lot of students will use this. And then what happens in here is you just need to switch your answers around, because in quadrant 2, all your x values will be negative. So the 1/2 will become negative 1/2. The √3/2 will be still √3/2 because in quadrant 2, y value is positive. And then for 45 degrees, which is 135, the negative √2/2 for the x, and then √2/2 for the y. And then for the 30 degrees, which is 150, so it's negative √3/2 and 1/2. So you kind of figure I'm color coordinates. This means that the blue one is the same, means it's 45 degrees or pi/4. The orange one is the same as 30 or pi/6. And the black one is the same as 60, or in this case is pi/3. And in quadrant 3, every single one of this value is negative because in quadrant 3, both x and y values are negative. And then in quadrant 4, only the y value is negative, the x value is positive. So so this is how we do the 30, 45, 60, or the corresponding to 120, 135, and 150. Then the question is, how do we do the 0, 90, 180, and 270? Now, just want to point out to you guys that when I use the word unit circle in this case means that your radius is 1. Okay, so in this case, that when you have a value on the 0 degrees, so if you talk about the unit circle, and since your radius is 1, so the 0 degrees is right here. So the coordinates in this case will be 1, 0, where your x in this case is 1, your y in this case is 0. So in this case, you will have a 1, 0 in your 0 degrees here. And then in the 90 degrees, which is up here, and again, don't forget the radius is 1, so you will get 0, 1. So your 90 degrees here is 0, 1. And then for 180 degrees, which is right here, again, your radius is 1, so this is negative 1, 0. And then for the 270 degrees is 0, negative 1. So that's why you get this 4 special coordinates that is not in the quadrant, but in your x and y axis in 0, 90, 180, and 270 degrees. So those are all, and these are all numbers are fixed here. Okay, these numbers are all fixed. So some of you were asking me is, how do you use this table? So depends. So if you are looking for sine theta, make sure you take out the y values. If a question is asking for cosine theta, you use the x value. If you're using tangent theta, you just take y over x because tangent is sine over cosine. So it's taking, so what in order for you to find what is the value for tangent, you just take this y value divided by the x value. Then you will get yourself your tangent theta. If you want to find the cosecant, secant, and cotangent, you just need to reciprocate it, just flip-flop it, and you will get yourself the cosecant, secant, and cotangent. So now I'm going to show it to you how we're going to use this kind of table to find this, okay, to do these kind of questions, because it's very easy. And again, class, in your test, I will provide you this circle, but no coordinates, no nothing. It's just this circle with this degree and radian and degrees and radian, no coordinates. So you have to figure it out yourself. So make sure you know how to do this. Practice is what it is. And you do, if you want a blank one, let me know because I can send it to you guys via email. So email me and I'll let you know. So for example, is if I want to use this, cosine theta is 1/2. So in this case, it's positive. So what you do is cosine is your x value. So you look at all your x values, which x values give you 1/2, and that will be your answer. So can someone tell me, look at this unit circle? Someone tell me what x value give us 1/2?
Pi over 3.
Pi over 3, or in degree is 60. So your answer is 60 and pi over 3. Anyone can also tell me another one besides 60 or pi over 3 that give you the x value is 1/2?
300 degrees.
Yep, 300 and pi over 3. Yep, is that easy now with that unit circle?
Yeah.
Yeah, so you so either, as I told you, right, either you memorize this, either you know how to fill in these coordinates, or you memorize that table. Remember that table I showed to you earlier on, this table. So I would recommend for you guys is to do this table, not memorize, just know how to do this unit circle. Now, secant. So in order for us to find secant, you need to do the reciprocal first. So can someone tell me what is the reciprocal of secant, what we call it? What is
Cosine?
the
Cosine?
cosine? Yes, that's correct. So if you want to find secant of 2, it's the same thing as cosine theta. But what happens to this 2? You have to flip it. And do we did this already in part A? Yes. So can someone tell me what is secant theta equals to 2? What is the theta in this case? It's going to be exactly the same, 60, 300, and pi over 3, and 5 pi over 3. So if you have secant, cosecant, cotangent, what you do is you flip it to become sine, cosine, tangent. But don't forget, you also need to flip-flop that value that you have at the back. Okay. All right, let's do another one. You guys try it, number 40. So cotangent theta equals to 0. So can someone tell me what is cotangent theta, the reciprocal is? What is reciprocal? It's gonna be
XY.
tangent, right? Okay, but when you flip this, it becomes 1 over 0. Okay, don't forget, when you flip the 0, it becomes 1 over 0. So this means that this is undefined here, because if you have a 0 in the denominator, it's undefined. So that means that if you look at your unit circle, tangent in this case is actually y over x. So that means that your y value has to be 1 and your x value has to be 0. Okay, so that's what it means by tangent. Tangent is y over x. So if you look at this unit circle, can someone tell me which angle give us y value is 1 and x value is 0?
Zero or 360.
That will be wrong, because don't forget, this is x and this is y.
90.
So 90 is correct. So in this case, your answer will be 90 degrees or pi over 2. Now, do not forget that this one can be plus and this one can be negative, because you will still get undefined. Because if you're, I don't care, right? As long as it's 0 is the denominator, your 1 can be plus or minus. So beside 90 degrees or pi over 2, what else will be undefined for tangent?
270.
270 or 3 pi over 2. So in this case, your answer will be 90 degrees, 270 degrees, or pi over 2 or 3 pi over 2. Okay, so that usually how many answers you should get here? You always get 2 answers if you go from 1 full circles. Okay, so this is part A. Okay, for part B, they ask you for secant theta equals to negative root 2. So anyone know what is the reciprocal of secant called? What's the opposite of secant? What is the reciprocal of secant? It will be
Cosine.
cosine, right? This is where we need to know this. And what is the, so what we need to do is we have to flip flop this. So become negative 1 over root 2. So we need to rationalize this. So we need to multiply this by root 2 over root 2. So this is actually negative root 2 over 2. Don't forget, it's a negative. And if you remember from the unit circle, what is cosine is for the coordinates, x or y? Cosine theta is your x or your y?
Cosine is x.
It's x. So this, you need to look at your x. Yes. So look at your unit circle here. What x value what angle give you
45.
negative root 2 over 2?
-2, right?
Negative what?
It has to be negative, right?
No, because your angle say it has to be in positive 0 to 360. So this is not negative. So look at your x value here in your unit circle. What x value will give us negative root 2 over 2?
135.
135 or 3 pi over 4. What
Mhm.
else? Negative root 2 over 2. Beside this one,
225.
225. Don't forget, this is color coded. Once you see blue writing, you're looking for the blue ones, okay? Because they're all color coded. So blue, they're all the same. Orange and the white and the black, sorry. And so this will be
For the
225.
second one.
I'm sorry.
I'm still kind of confused. The second one is a negative though. They're both negatives. Would that still be like the third quarter?
Yeah, because we need negative.
Or we need 2 negatives or just one?
Negative. Well, as I told you, right? All students take calculus. For cosine, which one is negative?
The
Quadrant.
fourth one or the third one?
No, cos. This is positive for cos.
Um,
So it should be quadrant what?
what's positive?
2 and 3.
Third
2
one.
and 3. Yes, it will be 2 and 3.
So basically, if it's on the left side, then that's a negative.
Yeah. So that's why
Yeah.
this will be in quadrant 2,
Oh, that makes sense.
and this will be in quadrant 3.
And then on the right, it's always positive.
This is 1, 2, 3, 4. Yeah. So that's the reason why you need to, implement this into your unit circles. And that means, as I told you, how many answers you get here, class? If you have whole 360 or 2 pi, 1 revolution, you got how many answers? You always get
2.
2 negative and 2 what?
Positive.
Positive. Yep.
But when I look at the, what is it called? The 7 pi over 4, you see how it says at the end, it says negative right here, 2 over 2.
This one, 7 pi over 4.
Yeah. When you see how it says SQRT 2 over 2, but then it has a negative on the second one.
Yeah, because of a negative, so this is not good. Because we are looking at the x value, not the y value.
Oh, yeah.
So we are looking at the x, not the y. So
Yeah,
be
yeah.
careful with this. Yeah. And
Yeah,
also we
yeah.
know that cosine is positive in quadrant 4, so negative won't work in this.
Yeah,
So you
I see
need,
that.
this is something that you guys need to really, really know. So I do recommend you guys to practice this kind because this will be asked in your test. Yeah, these kind of questions will be asked in your test for sure.
All right.
Yep. All right, so we're gonna move on because if you have any questions, let me know because we will after class we'll talk about it. So what we're gonna do here is we're gonna move on to how we graph sine cosine. So this is 6.4, which is what we concentrate here. So how do we graph this in this case? Let's put down here. This is your homework 6.3 here. I do have some graph already that I did last time, so I can. So in order for you to graph a sine and cosine, you do need to use your unit circle. So let's try the sine first. So in order for us to draw the sine graph, what you need to know is that your x in this, when you plug in your x and y, usually, right, you plug x and y, your x in this case has to be in angle, it must be an angle, okay? Because sine angle. So the number that we use here is gonna be on the 0, 90, 180, 270, and 360. So, but we're gonna use this in radian instead of degree. So your x in this case will be 0. And as you know that sine is your x or your y value. Sine is your
Y.
y. So if you look at 0 degrees, what is the y value for it? What is the y value? 0, yes. So sine 0 is 0. So your x, in this case, your y will be 0. Now, the next one we're going to move on is the pi over 2. So when sine is pi over 2, again, sine is a y value. What is a y value in this case?
1.
1. So this is 1. So I'm going to draw a line here so we know. And then the next one we're going to go is 180, in this case, pi. So what is the y value in this case?
0.
0. And then we go down to 3 pi over 2. So what is 3 pi over 2 for the sine 3 pi over 2 is?
-1.
-1. And what is sine 2 pi? Back to the here, it will be also what?
0.
0, right? So what you do here is, since we got these 5 coordinates, so we're gonna graph this. This 5 value is very important. So I put a star on it. So please, class, if you doesn't know how to graph a sine or cosine, watch this video again, because otherwise you lose like a lot of points in your test. So so we will break this into 5. 1, 2, 3, 4, 5, where this is your x. So we will have a 0, pi over 2, pi, 3 pi over 2, and 2 pi. So this is your x value here. And your y value is either 1, 0, or -1. So it's only between these two. So now we're going to draw the graph. So when x is 0, y is 0. So this is a coordinate point. So when x is pi over 2, sine pi over 2 is 1. Sine pi in this case is back to 0. Sine 3 pi over 2 is actually -1 somewhere down here. And then sine 2 pi is 0. So when you look at these 5 coordinates point in purple, you can actually draw the sine graph. So your sine graph actually looks like this. It is like a hill, and then down, and then go to the valley. So it's kind of like a hill and a valley. Okay. And this is kind of like what we call as one cycle of a sine. That means that if you want to continue drawing your sine graph to the right, because it keep on going, it will have the same thing, a hill and a valley. And this will be 4 pi, because 2 pi plus 2 pi is 4 pi. And then you can keep on drawing, hill and a valley, and then this will be 6 pi. Okay. And if you're going to do it on the negative side, don't forget the negative side, you do it opposite. So don't draw me a hill and a valley like this. This is wrong. Okay, so don't do that. So actually, if you want to draw the negative side, you have to draw opposite, means the valley and then the hill. And this will become a -2 pi because it's on negative side. The value in this case is exactly the same as here, but you just put negative. So -pi over 2, -pi, -3 pi over 2, and then -2 pi. So this is the sine graph for this class. You guys all right here for sine?
Can you show us one more example, please, for the graph?
Oh, we're going to do more than an example. This is just a basic graph.
Okay.
Yep. So this is a basic graph. So we will do more example. So don't forget, this is the basic graph. What is the meaning of a basic graph? Means that this is the graph without any transformation. Means we haven't moved up, down, left, right, and doing all this crazy transformation. This is just a basic graph for sine. Okay. We'll do the same thing for cosine in this case. So cosine, we still use back the same x value in here. So we will use 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we still use back the same 5 coordinates here. But don't forget, when you use the cosine, we are looking for what value? The x value or the y value for cosine?
X.
x. So if you look at the unit circle here, what is the cosine of 0?
1.
It'll be 1, the x value. So this will be 1. For pi over 2, what is cosine pi over 2 for the x value?
0.
It'll be 0. Cosine pi
-1.
will be -1. 3 pi over 2,
0.
0. Don't forget it's x value, not the y. And lastly, 2 pi.
1 again.
There'll be 1 again. Again, these 5 coordinates are very important, like what I just did in sine here. So again, when you draw the cosine graph, you do the same thing, 0, pi over 2, pi, 3 pi over 2, and 2 pi, same thing. And then you point the graph. So the first point we have in this case is 0, 1. So again, we have 1, 0, and -1. So 0, 1 is right here. So this is your first coordinate point here. Pi over 2, 0 is right here. Pi -1 is right here. 3 pi over 2, 0 is right here. And then the last one, 2 pi 1 is right up here. So what you notice when you draw your cosine graph is not going to be a hill and a valley. It's going to be a very deep valley. So you just go all the way down valley like this. Okay. So this is your cosine graph. And if I want to continue drawing on the right side, I just draw the valley in this case. So it'll be like, and this value is 4 pi. And if I want to do it on the right side, then you draw it the value on the backwards like this. And then this will be a -2 pi. So this is what we call as your cosine graph. So this is your sine and your cosine graph. And this is very, very, very important. Anyone have any questions? This is a basic sine cosine. Anyone have any questions for me here? Okay, so once you get, so I don't need my unit circle here. So this is how you draw your sine and cosine. The next thing you need to figure out is what is your domain, range, and so on, the period. So so in this case, in order for us to figure out what is the domain and the range and so on, so let's figure out the domain in this case. So since this graph goes continuing non-stop from negative to positive infinity, your domain in this case will be negative to positive infinity. That's your domain. Your range, since the lowest value you can have is a -1 and the highest value you can have is 1, so your range is -1 and 1 with a bracket, means that it includes those two numbers. Okay. The next one we're going to talk about here is your period. So your period in this case is 2 pi. What is period in this case? Period means that a cycle. Sometimes you call it a cycle. So that means in one cycle is 2 pi. Okay. And then you also need to figure out what is your x-intercept is. So when you look at your x-intercept for this, it's going to be 0, pi, 2 pi. This will be 3 pi if you want to do it. This will be 4 pi, 5 pi, 6 pi, -pi, -2 pi. So your x-intercept in this case is called k pi 0, where k in this case is integer. Integer in this case means 0, 1, 2, 3, 4, -1, -2. Okay. Your y-intercept in this case will be 0, 0, because they only intercept at here. This is on your y-axis. So, so your y-intercept will be 0, 0. And this is gonna be an odd function. The reason why I say this is odd function is because it's symmetry with its origin. So this is all about the sine wave. Now the cosine wave, which is the orange one, will also have the domain from -infinity to +infinity, means that this keeps on going to the value like this, so non-stop. Okay. Your range is also from -1 to 1. So if you look at this always go from -1 to 1. Your period in this case is going to be 2 pi. So short form for period is capital P. Now your x-intercept is a little bit weird because it's going to be pi over 2, 3 pi over 2. Can someone tell me what is this going to be? If I say pi over 2, 3 pi over 2, what is this x-intercept? And then this one. Look at the pattern. Pi over 2, 3 pi over 2. Anyone know?
5 pi over 2?
Yes, this will be 5 pi over 2. And this is what?
Would it be 7 pi over 2?
Mhm. And if so, you find out that the number here is odd 1, 3, 5, 7, 9, 11 over 2. Same thing with the negative one. This will be negative pi over 2. This is negative 3 pi over 2. If I have another one, it'd be a negative 5 pi over 2. Now, how do you write this as the k form? So since you have a pi over 2 starting from, so it's gonna be pi over 2 plus k pi. 0. So pi over 2, so when k is 0, again k is integer in this case, you will get pi over 2. When k is 1, you will get 3 pi over 2. So 1 plus half is 3.5. And when k is 2, 2 plus half is 5.5. So that's why this is the x-intercept for the cosine graph. The y-intercept in this case will be at 0, 1, because this is at right over here, 0, 1 here. This is your y-intercept. This is going to be an even graph because it is symmetric with the y-axis. So when you fold this graph on the y-axis here, you notice that this left side and the right side, they're kind of the same because they kind of reflection to each other. So this is the sine and cosine graph for.
Well, I have a question. What would go after the 4 pi? So for example, after the 2 pi, it was 5 pi over 2 and then 7 pi over 2. What would go after
That would be 4 pi. Then after that will be 7 pi, so it'll be 9 pi over 2.
So you just go up by 2?
Yeah, you just add half.
Okay.
You're adding half. So this plus half, plus half, plus half, plus half. You keep on adding half.
Yeah.
And this one, you keep on subtracting half.
Okay.
Same thing with the same here. Keep on adding half and keep on subtracting half. Okay. So you go here, you add half. You go there, you subtract half. This is just a basic graph. Okay. Because we haven't done any questions. Good. You guys ask questions.
I don't really get the x-intercept and the y-intercept like that.
X-intercept is right here. That means where they intercept here, right?
Mhm.
There are multiple x-intercept, right?
Mm.
And it's going to be 0, 1, 2, 3, 4, 5, 6 pi. So that's why the intercept here is k pi. Otherwise, you're going to write this forever for x-intercept. Pi, 0, 1 pi, 2 pi, 3 pi, 4 pi, the negative pi. So we just use it as k pi in this case. Same thing, but your y-intercept, you only intercept one time here on the graph. So that's why it's going to be at 0, 0 for the sine. For the cosine, the x-intercept is pi over 2, 3 pi. It's multiple for x-intercept. So that's why it's written down as pi over 2 plus k pi.
Okay.
The pi over 2 because it starts from pi over 2. And if you look at the next x-intercept, the difference is pi. You see that?
Yeah. So k pi means like multiple pi's. It just gives the
Yes, it's a multiple, but k in this case is integer. It means k can be 0, 1, 2, 3, 4, 5, or negative 1, 2, 3, 4, 5.
All right.
And same thing here, when you look at this, you'll find out that if you find the difference between 3 pi and 5 pi over 2, the difference is pi. So you've noticed that every single one here has a difference of pi.
Mhm.
So that's why the k pi came in, because that means it can be 1 pi, 2 pi, 3 pi, 4 pi, 0 pi, negative 1, 2. The y-intercept, you only intercept on this. This is where you only intercept on that. So it's 0, 1.
Yeah.
Right. So so this is the basic graph of it. So
I'm
now
actually, so I'm kind of confused on even and odd functions.
we'll talk this after class. This is you done it in your college algebra class. Even function means that it is symmetrical with the y-axis. Means that if you have a point here, it's the same as so if you have xy coordinates, you also will get negative xy coordinates, like x squared, like a parabola is an even function. Odd function is the one that's symmetrical to the origin. So this is not in my class. So if you want to know more about even and odd functions, please send me an email. I will send you some YouTube for you to watch, because again, this is done in college algebra, which is the one before. So I'm going to move on to something else. So even odd function, if you have any more questions that is not belongs to this class, that it belongs to the previous semester class, you need to talk to me, because that means you're not qualified to take my class. That means you didn't do well in the college algebra class. So I'm going to point out this is all trick stuff. So if you have anything if you doesn't know how to factor, if you doesn't know how to do like exponents, that is not in my class. That belongs to the previous class. So you have to brush those up. Now, so that is the basic graph we just learned. So what we're going to talk about here is we're going to talk about what happens if there are transformation. So so there are 4 different types of transformation possible, up to 4. Okay. So this is the transformation you need to know. This is important. Okay. So a sine bx minus c plus d. So the cosine, doesn't matter if you sine and cosine, they are the same. The only difference here is your graph is a little bit off. The sine wave and the cosine wave is a bit different. So we have a.
You're breaking out.
Am I breaking out?
Yeah, like I couldn't hear anything you said for this like thing.
Is that anyone can hear me or just her?
Maybe
Am I breaking out?
No, I can hear you just fine.
So notice you might check your computer. So so if I'm breaking out, let me know. You might have to rewatch this again. So so these are the 4 A, B, C, D. These are the 4 different transformation here that you need to know. So so A in this case is what we call as your amplitude. Okay. So what is an amplitude? Amplitude, which is capital A in this case, is the difference, the distance between the maximum and the minimum values of the function. So half, so you have to divide by 2. So you remember that when you guys draw a sine wave or cosine wave, so this is the max, and this is your minimum. So the amplitude in this case is this. This is your amplitude. That means half of your maximum and minimum if you do that, add them up to by 2. So it is denoted by this A, but it's actually an absolute value of A in this case. So in order for you to find the amplitude of a sine and cosine graph, you look at the number in front. And if this number, let's say, is 2, what happens is that usually in sine and cosine, it goes from 1 to -1. So if your amplitude is 2, then it will stretch out to 2 and -2. If your amplitude is 5, then this one will go 5 and -5. So the amplitude is just telling us how tall we go and how up and down, the range. Okay, it will affect your range in this case. So that is called the amplitude. The next one we have is called the B. So B in this case is what we use to find what we call as your period. Your period in this case is given us by the formula of 2 pi over B. This is very important. What is B in this case is this B is telling us what is the horizontal stretch and horizontal shrink. So this B, usually this is go from 0 to 2 pi. So if this B is 1, but if your B in this case is 2, then what happened is that your period in this case is 2 pi over 2, which is pi. So what happened is that this graph will be shrink by half. So it will become pi in this case. And if this b is 1/2, so this will be 2 pi over 1/2, which is the same thing as 2 pi divided by 1/2, which is 2 pi times 2, which in this case is 4 pi. So when you have a 1/2 for your b, this will be stretched by 4 pi to 4 pi in this case. So you'll be stretching double. So this b is actually telling us how stretched or how shrink it is horizontally, and it's denoted by b, and the formula to find it is to use 2 pi over b. Okay. Next will be the c. This c is what we call as your phase shift. This is a unit for this is a symbol for phase shift, which is the formula for phase shift in this case is c over b. What is phase shift? Phase shift means that you move your graph left or right. Okay, so this c is telling us you move the graph left or right. I just want to point out to you guys that this formula has a negative in here. So just want to tell you that if you have sine, let's say x plus pi over 2, do you guys know what is your c in this case?
Pi over 2.
No,
Positive pi over 2.
it will be negative pi over 2.
Wow.
Okay. So do not forget that your c initially is a negative. So if you have a positive, you have to switch your sign to negative. And what happens if this is a negative pi over 2?
And it's a positive.
Then it will be positive. So make sure you guys know that this c that we have here, you have to switch your sign. This is very important because so what does that mean in this case? That if your c is a positive pi over 2 means you go to the right pi over 2. If your c is negative pi over 2 means you go to the left pi over 2. So don't forget positive, negative. So that means so this is called the phase shift, means you go left and right. The good news is your b here is 1, so that's why you do not need to worry about it. So if your b is 2 or your b is 3, then you have to divide this by 2 or 3. So it does move things around. So what happens is, so if it's positive pi over 2 means your graph doesn't start at 0, 0 anymore. It will start at pi over 2. So your graph will look something like this now if you move it to the right, or if you move it to the left on negative pi over 2. So your graph will do something like that. So this phase shift is telling us we're moving left or right. And the last thing we're going to talk about here is D. D in this case is either you move up or down. So if it's a positive D, you move up like here. If it's a negative D, you move down. So what you do with this graph is if you move up, then this will move up, you know, or if you move down, you move down. So depends on the how high up and how high down you move. So these are the 4 transformations that we are doing in this case. So this is very, very important. Okay. And this is the 1, 2, 3, 4 that we talked about here. And the last thing we're going to talk about here is how do we move this one cycle? So we had to figure out the left and the right endpoints of one cycle. So what happens in this case is because when we do transformation, we need to figure out where does this start and where does it end. So once we know where it starts and where it ends, then we can figure out what will be the coordinates correspond to it, because we just need to divide this by 4. So every time when you have a full sine graph, if you know where it starts and where it ends, we just need to divide this whole thing by 4. We call it the period by 4. then you can figure out the rest of the coordinates that we have, because there are 4 quadrants. 1, 2, 3, 4. So that's the reason why we divide this by 4. So we will get all 4 different types. So how do we figure out where do we start and where did we end the point? Is you use this formula. You use to figure out where you start and end your one cycle. You solve bx minus c equals to 0 and bx minus c equals to 2 pi. So what you do here is you take this and you make it equals to 0 and you solve for x. And you also make that equals to 2 pi. And once you solve for x here, this will be where you start of your graph. And this will give you the end point of it. Okay, this is end. So this is how we figure out this starting and ending point. So this is used a lot when you graph this. So I will show you how we graph this. So before I continue with the graphing piece, so make sure you guys attendance. Yep, I know. So please put present down in your chat room for attendance. Yep. This is so now I'm going to teach you how to use this for this kind of graph. So so we have this. So this is very important. This is question 5 in your notes here. Y equals to negative cosine 2 pi x. So pay attention because this was around 10 to 12 points in your test. Okay, your first test. So so what we need to do first in this case is to figure out what is your A, what is your B, what is your C, what is your D. So don't forget the formula that we compare here is y equals to A cosine bx minus c plus d. So this is the formula. So can someone tell me what is your A, your B, your C, and your D here? A in this case will be
-1.
Yep, because this is the front. So A will be -1. Now, do we have a parenthesis in this question?
No.
No. So that means that B in this case is like slope, always next to X. So what is your B in this case?
2.
2 pi. Forget
2
that's
pi. Yeah. 2 pi.
It's 2 pi. And what is C and D in this case?
1
No.
or x.
No D.
X.
No C, no D.
No D.
In order for us to have C, you need to have parentheses. So if I give you a parenthesis plus pi, then this plus pi minus pi will be your C. And D usually given you at the end like this. So this will be a D. So we in this case, we don't have C, we don't have D. You guys all right?
Yeah.
Next thing we're going to talk about is the amplitude, the period, the phase shift in this case. Now, amplitude, the formula is the absolute value of A. So what is your amplitude in this case?
1.
1, because since A is -1, so you take absolute value is 1. Now, the formula for period in this case is 2 pi over B. And what is B in this case?
2 pi.
2 pi. So 2 pi over by 2 pi is what?
1.
1. Phase shift is C over B. But since you told me there is no C, so do we have a phase shift in this case?
No.
So we don't have a phase shift in this case. So if you don't have C, you don't have phase shift. So this is how you figure out your ABCD, your amplitude, your period, and your phase shift. So this is usually the first 4 points in your test. So
Do
make
you
sure you know how
provide-
to do it.
Sorry, do you provide the formula?
No,
For the
I want to tell everyone here in class, no formulas are provided in any test. Okay, no formulas. You have to know this. Now, the next thing you need to point out here is the original points here. Now, I'll fill in this table here. So what is the meaning when I say original points in this case? The original points in this case is asking us about the 5 points that we used early on. Now, if you remember the 5 points that we used for cosine, now if you forget it, it's fine. I can show it to you, the 5 points. So the 5 points that we're talking about here is these 5 points. Remember the cosine? These are the 5 points. 0, 1, pi over 2, 0, pi negative 1, 3. These are the 5 points I'm talking about for cosine. If I ask for sine, then these are the 5 points I'm talking about. So in this case, the 5 points the original 5 points that you put in here will be consist of these 5 coordinates. So it will be 0, 1. Yeah. This is tough. I told you this class is difficult. You haven't seen the calculus part yet. This is just trick. And then pi over 2, 0. Oops. And I'm going to tell you when you get a calculus, there is no formula provided to you either. This is not high school, so nothing is provided. So 0, 1, pi over 2, 0, pi negative 1. And then the next one will be 3 pi over 2, 0. And the last one is 2 pi 1. So this will be your 5 original points here. So make sure you know how, that's why I said put a star on it, on both of this, because this is cosine. And if I do the sine one, like question 6, then I have to use this 5 original point here. So it will be 0, 0. So this worth 1 point in your test. So if you do not know your 5 original points, you will lose a point here. Pi over 2, 1. And then this is pi 0. 3 pi over 2 negative 1. And then the last one is 2 pi 0. So make sure you guys know, are we doing sine or are we doing cosine? Because if you do sine and put cosine points, cosine you put sine points, your graph is all going to be wrong here. Okay, so this is how you figure out your original points. 0, 1, pi over 2, 0, 3 pi over 2, pi negative 1, 3 pi over 2, 0. Now, I want to point out to you that some of you asked me, is other instructor don't allow formulas in the test? I can tell you that yes, none of the formulas teachers will allow you to have formulas in your test. So these are the 5 original points. And now you need to figure out your final points. Now, this is more important because this final point is where you begin to draw your graph here. So how do you find your final point? So please pay attention. This is very, very important. So in order for us to find your final point, you have to use the bx minus c equals to 0 to figure out where you start and where you end, where you use bx minus c equals to 2 pi. And if you look at our formula, your bx minus c in this case is inside the parenthesis. And since the only thing that is in the parenthesis is 2 pi x, so this is actually 2 pi x equals to 0 and 2 pi x equals to 2 pi. And now you begin to solve for x. So I divide both sides by 2 pi here. So what is my x in this case? X in this case will be what?
1.
1 here on the ending part. And what is 0 divided by 2 pi?
0.
0. So what happened is that you start at 0 and you ends at 1.
1.
So this is what the starting and the ending point here is. You start at 0. That means this cosine graph that we will draw, you will start at 0 and you will end at 1. That's what this starting and ending point means. Now, because there are 4 quadrants, so what you do is, in order for us to figure out what are the x value for the 4 quadrants, so what you do here is you need to take the period divided by 4. The reason why you take the period divided by 4 is from 0 to 1 is your period. And since we got 4 quadrants, so that's why we have to divide this by 4. So, so the period you found early on in the beginning is 1. So it's 1/4. So what happened in this case is you have to add 1/4 to the next one. So 0 plus 1/4 is 1/4. And then you have to continue at 1/4. 1/4 plus 1/4 is 1/2. And then 1/2 plus 1/4 is 3/4, 3/4. And then 3/4 plus 1/4 is 1. So this is how you figure out your x value. In this case, means that this is from 0, 1/4, 1/2, 3/4, and 1. Okay, so this is how you figure out your x values. Now we need to figure out your y values. So in order for us to figure out your y value in this case, you need to look at your a and your d. So you take the, if you have a, you have to multiply by it. And then you either add or subtract d in this case. So what do I mean by add, multiply a and add, subtract d? So if you look carefully on what we have here, a in this case is -1. So in this case, we need to take all your y value, multiply by -1. The good news is the d is nothing, so we don't have any d. So what you do is, you remember all the original y values that you have in here. You have to take this all y values and you have to multiply this by -1 because the a here is -1. So 1 times -1 is -1. 0 times -1 is 0. -1 times -1 is 1. 0 times -1 is 0, and then 1 times negative is 1. So what you need to do here, class, is this final 5 points is your graph. So what you do here is you graph them up. So you have this graph. Your is 0 and negative. Your y value is either 0 or -1. Your x value is between 0, 1/4, 1/2, 3/4, and 1. And the first one we have is 0, -1. 0, -1, the point is right here. 1/4, 0, which is right over here. 1/2, 1, right over here. 3/4, 0 is right over here. And last one is 1, -1 is right over here. So this is your cosine graph that you have. Oops. And in the test, usually I want you to draw me 2 cycles. 2 cycles means you have to draw me another cycle. So you have to draw me like either one of this right here, or you draw it another one looks something like this. So this is 3 cycles really. So in the so usually the first cycle you need to dot your coordinates. The next cycle you do not need to dot it. You just need to figure out what is like here to here is 1 unit. So what you do here is you just click them 1 unit each. So example in this case is if I want you to draw it on a graph paper here. I'm going to dot it so you can see it. So we got the first one that we have here is 0, -1. Let's say this is -1, so 0, -1. And then the other one is a quarter zero. And then the next one is half one. And then the next one we have is 3/4 zero. So it's some here. And then half, then 1 negative 1. So this is the sine graph that I draw just now. And then what you do next, I need 2 cycles. So either you draw it on the right side or the left side. So if you want to draw it on the left side, then you just draw like following what you have. So every points, or if you want to draw it on the other side, you can draw it like that. Do you guys see what I'm trying to say here? So this is the graph of your, so if you connect these dots and draw, make sure when you draw the graph, class, don't draw zigzag like this. I will take points off. All your sine and cosine graph, this follow cannot be pointy. It have to be smooth. It have to be like this, like a parabola. Okay, so don't draw like zigzaggy like this. Okay, so just connect this. So in the test, I do want you guys to give me the 2 full periods in this case. Anyone have any questions how we do this kind of work? And definitely, I will go through some examples here. I will go through another examples. Let's do number 7. No, I'm going to do sine. That's number 8 because this is sine. So 2/3 sine x/2 minus pi/4. So can someone tell me what will be your A, B, C, and D here?
A is 2/3.
2/3. B
Is x/2.
again, like slope, you don't need x, so it's just
2
1/2.
or 1/2.
C, this is important.
Pi/4.
Very good. So don't forget that if you have a negative, positive. If you have a positive, negative. Okay. Do we have a D in this case?
No.
We don't have a D. So this is the first thing you need to tell me. And then I will also ask you for amplitude, period, and phase shift. So what is your amplitude in this case? Absolute value of A. So it will be just
3.
2/3.
Okay.
Period is 2 pi over B. And
Which
what
is
is,
which is 4 pi.
yep, which is 2 pi over half. So if you have a calculator, you can always do 2 pi divided by 2 divided by point. You don't have a pi, so just do 2 divided by 0.5. You will get 4 pi in this case. Yep. Now, what's the formula for phase shift? It's C over
B.
B, right? So C in this case is pi/4, and B in this case is 1/2. Does anyone know how to do a fraction divided by a fraction? Because this is something a lot of students cannot do in my test.
Isn't that pi/8?
No. So this is
Multiply.
pi/4
2/1. Just 2.
divided by 1/2, which is the same thing as what?
Decimals
Times 2.
are
Times 2, right? Yes. So as you know that when you divide, you change it to multiply. You flip the back fraction, right? So what is pi/4 times 2?
Pi/8. What?
2 goes into 4 how many times? It's 2/1, don't forget.
What?
So in this case, it's what?
2.
Pi/2, not pi/8. If this is in the denominator, then this is pi/8. But since this is on top, this is pi/2. So this is how you figure out your period, your amplitude, and your phase shift. Now we're talking about the sine. Then you need to figure out your points here. So you need to figure out your original points. and then your final point. So since this is sine, so sine, the original point is the sine one. This is the one that we're talking about. So the original point is 0, 0, pi over 2, 1. This is a sine. Pi 0. 3 pi over 2, negative 1. And then the last one is 2 pi 0. So this is how you figure out your 5 original points here. So now we need to figure, and this is fixed. Some of you ask me, is this number fixed? Yes, this is fixed for sine and this is fixed for cosine. So you cannot change this original points. Okay. So now what we need to figure out is your final points here. So if you remember last time, in order for us to figure out your final points, you have to take the starting point and the ending point, right?
Mhm.
You have to take the bx minus c. Can someone tell me what is bx minus c in this case? If you look at this question, it's your original question.
Is it in the parentheses?
Yes, everything inside the parentheses. So what it will be?
X over 2 minus pi over 4.
Okay, so this is your bx minus c, and for the starting point, you always make them equals to what?
2 pi.
No, starting point always equals to
Uh,
0.
0.
Ending point is where you equals
2
to
pi.
what? Yes,
2 pi.
so make sure you know that this is again fixed. So you ask me, is that always 0 and 2 pi? The answer is yes. And the reason why the starting and ending point is 0 and 2 pi is because originally we start at 0 and we end at where?
2 pi.
2 pi. So that's why it's always equals to 0 to 2 pi, but that's where we start from 0 and ends at 2 pi. So now we need to solve for x. So I want to move this over here. So x over 2 equals to pi over 4. And then I multiply this by 2 because I need to get rid of this 2. So I times 2 on both sides. So x in this case is what? Anyone know what is x here? This is the same as what we just did over
Pi
here,
over
right?
2. Pi over
Pi
2.
over 2, yes. So usually the starting point is always the same as your phase shift. So if you so this starting point is always the same thing as your phase shift.
Is it always like that?
Mm-hmm.
Okay.
Yep. If your phase shift is as if you don't have, last time we don't have a C, right?
Yeah.
So then this will be 0. Mm-hmm. So if you don't have a C, then your starting point will be 0. But since we have a phase, so yes. So this is how we check if your work is correct. Your phase shift and your starting point should be the same. So for this case, we do the same thing. We add pi over 4. Can someone tell me what is this? Is when I add pi over 4. You guys got calculators, right? Can someone tell me what's 2 pi plus pi over 4 is?
3 pi.
No. Think about money. You got $2 and you add a quarter. How much you have?
3
You got
pi
$3?
and a quarter. Oh, no. 2 pi and then half of a pi.
So how do you write that? How is $2 and $2.25,
1/4?
right?
Oh, yeah. 1/4.
How do you write that? And then you multiply this by 2 later on to get rid of this 2. Anyone? This will be 9 pi over 4. You know how I get it so fast? When you add this, you get what? 2 1/4, right? And convert. Do you know how to convert this to improper? 2 times 4 plus 1, right?
Yeah.
So that's why I get 9 pi over 4. And then you multiply this by 2, so this will cancel out, become 2. So where you end at where? 9 pi over 2. So this is your end point. So now your start point is at pi over 2. And your end point will be at 9 pi over 2. And now we need to figure out what do we need to add. So we take your period divided by 4. Does anyone know what is the period for this case?
4 pi.
Will be 4 pi. We just did it early on. So it will be 4 pi over 4. So what we need to add here?
Pi.
Pi. So you just need to keep on adding pi to it. So can someone tell me what is pi over 2 when you add pi?
3 pi over 2.
And then you have to continue adding pi. So what is 3 pi over 2? Add another pi. It will be 5 pi over 2. Add another pi together. 7 pi over 2 and add another pi, you get 9 pi over 2. So this is always will match. So if you add another pi, you don't get 9 pi over 2, something is wrong here. So make sure you double check your work. So you should be adding, you should be like Sudoku, guys, Sudoku, right? So you should all fix very nicely, okay? Next thing is we need to figure out your y value. So what do you do with your y value in this case is, this is very important, is you take it multiplied by a and then plus minus d. Now, since the a in this case is 2/3, so we just need to take all the y values multiplied by 2/3. The good news is the d, we don't have a d, so we do not need to add minus d. So what you need to do is to take all these x values all this y value that you have here, the original y value, and you multiply it with 2/3. So 0 times 2/3, you still get 0. 1 times 2/3, you get 2/3. 0, you still get 0. This will become negative 2/3. And then the last one is 0 because 0 times 2/3 is 0. So this last point is important when you graph. Yes.
If you did have a domain, what would you do? You would multiply and then add?
No. If you have a d, you multiply first, then you add, like follow orders of
Okay.
operation. Not
If it's
domain.
negative, you subtract.
Yep. If you have a minus, let's say this is a -1, then once you multiply by 2/3, you have to subtract 1. So 0 subtract 1 is -1, 2/3 minus subtract 1 is -1/3. You know what I mean?
Yeah.
So you had to do all the math in this case. But we don't have a d in this case. So if you have a d is -1, you subtract 1. If d is +1, you add.
Yeah.
So with this, you can graph your graph here. So I'm going to show you how to graph this. So this one is what we need to graph, this final piece here. Okay. So that's why you need, once you know your final 5 points, and graphing is easy. You start with pi over 2. Now, just want to point out to you guys that, so if, let's say you have graph papers, right? So if you start out, this is pi over 2. Then where is 3 pi over 2 located at? Is it right over here, here, or here? 1, 2, or 3? Where do you put 3 pi over 2 at?
Why does it
Is it-
matter?
It does matter. Because if you put in the wrong one, your graph will look really messy. So where should we put 3 pi over 2? Is that on number 1, number 2, or number 3?
Number 1.
Number 2.
Okay. Number 1 is wrong. This is where majority of you put number 1. That is where you get wrong. Do not forget that now I tell you why it's wrong here. Your graph will be really messed up if you put it in number 1. Because what is the unit from 0? This is pi over 2, right? And since you have to add pi, so it means you have to go 2. So this is actually 3 pi over 2 is right. So you cannot put it in number 1, because if you put it number 1 here, you will get it wrong. So just want to point out to you guys, be careful with this, especially when you draw the graph, because your graph will look really weird. And if I want to do 5 pi over 2, should I go 1 or should I go 2? Should I go 1 next to it or should I go 2? Which one should I put? 2, right? So so sometimes it's 1, sometimes it's 2, depends on your what you add on. So just want to point out to you guys that it does have an important role here. And then 7 pi over 2, you have to move 2.
So how do you know when it's a 1 or 2?
You have to look at your what have you put in here and what have you put in here.
Hmm.
And you have to use your common sense. This is 1/2. If you draw me a number line, if this is 0.5, can you put the next one 1.5?
No.
That's the reason why you had to put the next one 1.5,
Right.
because this is half. This is 1.5.
So what would be an example of it being on number 1? Like what would
If this is pi over 2,
Oh, okay.
then you will be number 1 because you add 1.5 half.
Yeah. Okay.
Mhm. So
it depends
again,
it depends on your period, basically.
yes. So it's all mostly you have to think about it before you draw it. Don't just simply dot dot dot.
Yeah.
So
yeah.
make sure you have to think about it, because this from here is half, and this is 1. So that's why you have to watch out carefully. So and we have what the range is from 2/3 to -2/3. So this is 2/3 and -2/3. So the first one is pi over 2, 0. So I'm going to screen again. So this will be over here, pi over 2, 0. Next one is over here. And then next one is 5 pi 2, 0, 7 pi 2, 2/3, and 9 pi over 2, 0. So your sine graph, which usually, as I say, the sine graph is the hill and the valley. This one is, oops, sorry, my bad. This is wrong. This is what happens. This is positive 2/3. I thought it's negative. So this is actually up here. And then this is down here. This is negative 2/3, which is right down. So I kind of figure out that this is wrong is usually because usually you have a hill and a valley. The one that I just draw just now has a valley and a hill. This is only happens when you have a negative in front of your A. If your A is a negative, then you'll be reflect on the y-axis. But since since we don't have a negative, so this is not the correct graph. So this is a graph for him. So if you want to continue drawing, you just continue drawing, but make sure that this one is spread out a little bit more than what we did last time. So if you remember last time we did, this is all like one unit. So this time, if you want to draw this graph, it will be, let's say this is 2/3. So this is pi over 2 here. And then the next one we have is a 3 pi over 2, 2/3. So you have to go 2 and then up. So let's say this is 2/3 here. And then you go 2 down, 2 down, and 2 up. So this is the graph of this basic graph here, the sign for question 8. You guys with me here? And then if you want to draw more, then you just, because there's no room here, so don't continue on the right side. If you do this in your test, do on the left side. So you go 2 down, 2 up, 2 up, 2 down. So this will be your 2 cycles in this case. You guys all right? This will be the graph. Right. So that's it for today. So make sure you guys really this is hard. This is not easy. So first thing is your homework due tonight will be what section? 6.2 and 6.3. And then you only got one homework due on next Wednesday, which is 6.4, which is this one. So I really recommend you to spend some time on 6.4 here, because once we finish what the next thing that we talk about here is 6.5. So 6.5 is where we do tangent, cotangent, secant, and cosecant here. So if you doesn't know how to do sine and cosine, then forget about 6.5. Okay, so make sure you concentrate how to do this one first. If you do have questions, do send me any emails or anything with me. I do have some old Zoom meetings, Zoom videos you can watch. So so I'm going to stop sharing here and I'm going to stop recording.